Sigma fi xi upon sigma fi, or you can write n, that means the total observation, which will be same 28 upon 10, which is 2.8. So this method is called to be the direct method to find mean. So in our previous slide we have seen this last example, which was having total frequency only as 10. Means I was considering the marks of only 10 students, and even the observations were small. That means it was just a 10 mark test. Sometimes the values of this xi and fi are too big, right? So the calculation of fi and xi will become too difficult, as well as it will become tedious for us to find out the values of this numerical calculations. And so for getting rid of such kind of tedious and time consuming method, we need to learn a new method that is called to be assumed mean method. Now what is this assumed mean method? Assumed mean method means x bar is equal to a plus sigma fi di upon sigma fi, which is equal to n. So here we will make a different table from this simple or direct method. In place of having only 3 columns xi, fi, then fi xi, we will be making nearly 5 columns, in which we will find out the class mark. And specially assumed mean method is used for such kind of data having not only single ungrouped observation but classes. So let us learn this method with the help of one example. So students, you can see classes over here 50 to 52, 53 to 55. These are all non-continuous class. Frequency fi is also large, right? So we will obtain the third column of xi, which is actually class mark, and which is the mid value of these two numbers, the lower limit and the upper limit of the given class. So we people know 50 plus 52 is 102 upon 2. So the class mark of this first class will be 51. Same way 53 plus 55 upon 2 will give you 54, 57, 60 and 63. These are the value of xi. That means this is the first observation of class mark x1, then x2, x3, x4 and x5 respectively. The fourth column what we have is di. That stands for deviation. Deviation means out of these 5 values of class mark, normally the middlemost value is considered to be a, and this a stands for assumed mean. So we are going to subtract each of xi, okay? We are going to subtract each of a from the value of xi. That means 51 minus 57, which will be minus 6, means we are subtracting the value of a from the first observation x1. Same way 54 minus 57 will become minus 3, 57 minus 57 will become 0, 60 minus 57 will become again 3, and 63 minus 57 will become 6. Now multiply this second column with the fourth column, that means the value of fi with di. So we will be getting product fi di as 15 into minus 6 minus 90, 110 into minus 3 minus 330 and so on. This will be 0, 345 and 150, right? Now if you calculate the total of all this, right, so you will be getting the summation of sigma fi di, which is equal to 75. Same way you can also find out the total frequency. So right now it is sigma fi is equal to 15 plus 110 plus 135 plus 115 plus 25, which is equal to 400. So you need to write it specifically here. Assumed mean A, you can also write it with the help of small a, is 57. Sigma Fi di is the product, summation of the product of frequency with deviation is 75, and sigma Fi means the total observation is equal to 400. Only these three things we need in the calculation. So our value of x bar, that means mean, is equal to a plus sigma Fi di upon sigma Fi, which can be written as n also, will be equal to 57 plus 75 upon 400. If you divide this number, you will get the value to be 0.1875. So it will be 57 plus 0.1875, which is finally 57.19.